Prior to sending information over the air interface, in either a traffic channel or control channel, the signal is processed. The PCM-coded speech coming into the TRC, or BSC-TRC, on the air interface is delivered at 64 kilobits per second. 8 of these channels would yield a bit rate of 512 kilobits per second over the air interface, with no transmission reliability added. The Transcoding and Rate Adaptation Unit, TRAU, in the TRC, or BSC-TRC, divides the PCM-coded speech into segments of 20 milliseconds. These 20 millisecond speech segments are then fed into the speech coder. The speech coder will analyze the segments and perform a reduction of the bit rate. The output is coded speech with acceptable speech quality at a rate of 13 kilobits per second. Next, 3 kilobits per second of in-band signaling is added to the 13 kilobit signal for a total of 16 kilobits per second going out on the ATER interface or A-BIS interface. Channel coding is used to detect and correct errors that have been identified during the signal transmission process. These signal errors are measured as a percentage of the total bits transmitted. Channel coding is performed inside the TRU for the downlink signal and in the mobile for the uplink signal. There are 2 types of channel coders used: block coders and convolutional coders. The speech coder delivers 20 ms slices of speech containing 260 bits of speech information. The 260 bits of information is divided into 50 very important bits, 132 important bits, and 78 not so important bits. 3 parity bits are added to the 50 bits, block coding. These 53 bits, together with the 132 important bits and 4 tail bits, are convolutionally encoded to 378 bits. The remaining bits are not coded. Mini-link microwave radios provide an efficient and rapid way of developing wide-coverage telecommunication networks. The use of mini-link is particularly suited for cellular applications because of its flexibility, concerning capacities, configurations, and space required. It also offers fast deployment in all project phases, from planning to commissioning. Mini-link is ideal for rapidly providing medium-capacity links in temporary or permanent, mobile or fixed communication networks. It can be used anywhere within the network, where 1 to 17 2 megabits per second transmission lines are required. As there is no need for heavy masts or towers, it can quickly be mounted on existing buildings or structures. The channel coding process is only effective in detecting and correcting single errors. Bit errors often occur in bursts of information sent over the air interface. This is caused by long fading dips that affect several consecutive bits. A process called interleaving solves this problem by separating the consecutive bits of information in a message and transmitting them non-consecutively. This helps overcome problems caused by bursts of noise. Through interleaving, single frames of information are spread out over several bursts. The data services in a mobile network are generating traffic in constantly increasing volumes. GPRS and enhanced GPRS, eGPRS, make it possible to send packet data over the GSM network. GPRS, eGPRS connections use the common pool of physical resources across the radio interface. Several technologies exist to handle the data services in a GSM network. The circuit switch data rate can be up to 14.4 kilobits per second per air interface time slot. Using the HSCSD technique, a circuit switch data rate of up to 56.7 kilobits per second can be achieved. This is going to result to approximately 12 kilobits per second user data rate per air interface time slot. GPRS makes it possible to send packet data over the GSM network. eGPRS increases the data rate for packet data services compared to GPRS through the introduction of a new modulation method and coding scheme over the air interface. The coding schemes CS1 to CS4 are used in a GPRS and MCS1 to MCS9 in eGPRS. The system allocates the air interface resources attempting to provide the highest user rate and enters therefore a proper coding scheme. GPRS, eGPRS connections use the common pool of physical resources across the radio interface in coexistence with the circuit switched system. This makes it possible to mix GPRS, eGPRS channels with CS channels in a cell. Equalization is the process used to overcome time dispersion. Time dispersion is when transmitted signals being reflected by objects far away from the RX antenna arrive at the antenna later than the original signal. The equalizer can handle reflections delayed by about 15 milliseconds, which is a signal path of about 4.5 kilometers. It creates a model of the transmission channel and calculates the most probable transmitted sequence. Data is transmitted in bursts, which are placed within time slots. In the middle of the burst, a training sequence of a known pattern with good autocorrelation properties is established. This training sequence is used by the equalizer to create the channel model. This model changes all the time, but during one burst it is considered to be constant. Rayleigh fading, due to near-region reflections, influences the reflected signal. This signal has an independent fading pattern compared to the direct one and can be used by the equalizer to enhance performance. With the dynamic BTS power control feature, the output power of a base transceiver station, BTS, can be controlled during a connection. The control strategy is to maintain a desired receive signal strength and quality in the mobile station, MS. The aim with BTS power control is to increase the number of MSs with sufficiently good carrier to interference ratio, C by I. BTS power control will improve C by I if traffic is maintained, or maintain C by I when traffic is increased or tighter frequency reuse is realized. The gain is obtained by a reduction of the overall interference level, I, in the network. When BTS power control is used in all BTSs in the network, the total amount of radiated power is reduced compared to when it is not used. This implies that the downlink and adjacent channel interference in the network is reduced. Frequency hopping, together with BTS power control and DTX, improve the possibilities to achieve very tight frequency reuse. Ciphering is a technique used in GSM to minimize eavesdropping. Ciphering involves taking a portion of the digitized signal stream of ones and zeros and combing it with a random stream of ones and zeros. This random stream is known only by the mobile station and BTS. The result is a signal that is unintelligible to all mobile stations or anyone else and can only be deciphered by the station with the matching code. The A51 and A52 encryption algorithms are available for use in GSM. The network operator has the option of operating in the unciphered mode or either encryption algorithm if they desire. The output power of a mobile station, MS, can be controlled during a connection. The controlling strategy is that a desired signal strength and quality shall be received in the base transceiver station, BTS. This user description describes the MS power control algorithm for circuit-switched connections only. The battery consumption is reduced in the MS, therefore recharging is needed less frequently, and the maximum possible speech time will increase when MS power control is used. The aim of MS power control is to increase the number of connections with sufficiently good C by I. When MS power control is used by all MSs in the network, the total amount of radiated power is reduced. This implies that the uplink, co- and adjacent channel interference in the network is reduced.